Hello everyone, welcome to this session on Numpy, iterating arrays and copying arrays. In this lecture, we are going to learn how to traverse Numpy array of different dimension and understand different methods used to copy array. Let's begin with an array iteration. Iterating array. Iteration means accessing each element of an array one by one. Depending on the number of dimensions, the method of iteration changes. For a one-dimensional array, a single loop is sufficient. For a two-dimensional array, the nested loops are required. Similarly, for a three-dimensional array, three nested loops are needed. Numpy also provides the np.nditer function which simplifies iteration regardless of the number of dimensions. Now, let's understand each one with example. First, we are going to discuss about iterating a one-dimensional array. A one-dimensional array is similar to a normal Python list. Since all elements are stored in a single row, we can access them by using a simple for loop. Now, let us understand the program. So we are working with Numpy. So we have to import the Numpy module by using this statement import Numpy as np. Then I am creating a single dimensional array by using the function np.arrayof and store it in a variable a. Then for I in a. This for loop start iterating through array a. During each iteration, one element from the array is stored in a variable I. Initially I equal to 10, next I equal to 20, next I equal to 30, finally I equal to 40. Then print of I. This statement print the current value stored in I. Since this loop visits every element, all four values are printed one after the other. Next, we are going to see about iterating a two-dimensional array. A two-dimensional array contains rows and columns. Therefore, a single loop cannot directly access every element. We need nested loop. The first loop accesses each row while the second loop accesses each element inside that row. Let us understand the program. So here I am creating a two-dimensional array by using the function np.arrayof and store it in a variable b. Now the array contains first row 1, 2, 3 and the second row 4, 5, 6. For row in B, the outer loop iterates through the array B. Instead of accessing individual value, each iteration accesses one complete row. During the first iteration, it accesses 1, 2, 3. During the second iteration, it accesses 4, 5, 6. Then for element in row, the inner loop now iterate through the current row. Each value inside that row is stored in a variable element. Print element comma end equal to single quotes. So this statement it print every element. Then end equal to this double quotes. It prevent the cursor from moving to the next line. Instead, it leave a space after every number. So all the elements of one row appear on the same time. Then print off. After finishing one row, this statement move to the cursor to the next line before printing the next row. Next, we are going to see about iterating three-dimensional array. A three-dimensional array consists of multiple blocks. Each block contains row and each row contains element. Therefore, we require three for loops. Let us understand the program. Here I am creating three-dimensional array by using the function np.arrayof and store it in a variable c. Okay, now we are going to access this three-dimensional array by using the three for loops. For matrix in C, the outermost loop iterate through each matrix in the array C. During the first iteration, the matrix contain 1, 2, 3, 4. During the second iteration, the matrix contain 5, 6, 7, 8. Then for row in matrix, the second loop access one row from the current matrix. For element in row, the innermost loop access one element from the current row. Each element is stored in a variable element. Then print element comma end equal to double quote. This print every element with the space after it. Then print off. So this statement after completing one row, it moves the output to the next line. So, as the number of dimension increases, the number of nested loops also increases. It will be making the code more complex. So, we are going to use the iterating np.nd_iter_of function. So in the previous slide, we used a nested loop to iterate through two-dimensional and three-dimensional array. As the number of dimension increases, the number of nested loop also increases, making the program lengthy and difficult to maintain. So Numpy provides a powerful function called np.nd_iter_of. So this function, it allows us to iterate through array of any dimension through a single loop. Let us understand the code by using this snippet. So here I am using the array C, that is, in a previous example we created one three-dimensional array and stored it in a variable C. So the same array I am taken here also. Okay, so see the code here. So the same array I am taken here. Then for x in np.nd_iter_of_c. So this np.nd_iter_of_c, it creates an iterator for the array C. Unlike nested loop, np.nd_iter_of automatically traverses every element regardless of the number of dimension. During each iteration, one element from the array is stored in a variable x. First iteration 1, second iteration 2, third iteration 3, and so on, eighth iteration 8. So print x, this statement print the current value stored in x. Since np.nd_iter_of visit every element individually, all the elements are printed one after the other. So the main advantage of np.nd_iter_of is that it works for one-dimensional, two-dimensional, three-dimensional, and even higher dimensional array without changing the loop structure. Next, we are going to discuss about copying array. Sometimes while working with array, we need another array contain the same data. Numpy provide different method to copy array. The three commonly used methods are using np.empty_like_of function, using np.copyOf function, using assignment operator equal to. So np.empty_like_of function, so what it will do, it manually copy the elements. Then the second method np.copyOf, which creates an independent copy of the array. Then the third method assignment operator, although it looks like copying, it actually create another reference to the same array. Now let us understand each method with example one by one. So first we are going to see the first method using np.empty_like_of. So the np.empty_like_of function create a new array with the same shape and data type as the original array. However, the new array initially contains uninitialized value. Therefore, we must manually copy each element. Let's understand the program. So here we are working with Numpy. So I am importing the Numpy module, import Numpy as np. Then I am creating a single dimensional array by using the function np.arrayof and store it in a variable a. So this was my original array. So this a was my original array. Then b equal to np.empty_like_of a. So this function np.empty_like_of create another array called b. The new array has the same size and data type as a, but its elements are not copied automatically. Initially, the values inside b are undefined. Then for I in range of len of a, the len of a function return the total number of elements in array a. Range of function generate index value from 0 to 3. The variable I, it stores each index one by one. Then b of I equal to a of I. This statement copies one element from a into b. Then from a, all elements will get copied into b. And this was the original array and this was the copied array. So this method perform manual copying because we copy each element individually using a loop. Next, we are going to see the method 2 using np.copyOf. So this is the easiest and safest method to copy array. The np.copyOf function create a completely independent copy. This is called deep copy. Changes made to the original array do not affect the copied array. Let us understand the program. So first we have to import numpy as MP. We have to import the numpy module. Then I am creating array, single dimensional array by using the function np.arrayof, and I stored it in a variable a. So this was our original array. Then b equal to np dot copy of a. So this line creates a new array b by copying all the elements of a. Unlike assignment, this creates completely separate copy. After this, I am changing zeroth position value. Initially it was 10, now I am changing as 99. After this, I am printing original array and copied array. So see the output here. Original array the value get changed, but in copied array the value doesn't change. So the main thing here was, since np.copyof, it creates a deep copy. The original array and copied array are completely independent. Any changes made to one array will not affect the other. Next we are going to see about method 3, using assignment operator equal to. Now let's see the assignment operator. Many beginners think this creates a copy. Actually it does not. Instead both variables refer to the same array in memory. This is known as shallow copy, or we can say reference copy. Let us understand this by using the code. So initially I am importing numpy by using the statement import numpy as np. Then I am creating one single dimensional array by using the function np.arrayof and stored in a variable a. Then I am printing the original array, and then I am changing the original array 0th position. I am changing the value as 99. Previously it was 10. I am changing that as 99. Then b equal to a. So this statement does not create a new array, that is this b equal to a. This assignment, this does not create a new array. Instead the variable b point to the same memory location as a. So both variable refers to the same array. So after assigning, I am changing the first position value also 88. After this I am printing the original array and the assigned array. So see the output, whatever I am changing in a original array, the same will be replicated in a assigned array, because it's a reference copy. Both will be point outing the same array. So I hope you will understand for iterating array and copying array in this session. Thank you for watching.